Welcome back to Lesson 92. Today we're going to talk about uniform motion problems with equal distance. So let's say, for example, that you go to your grandma's house. Your mom drives you. And we know that that distance is 20 miles, right? So your mom drives you from your house, say this is your house, to grandma's house, right? And mom, when she drives, takes 20 minutes, right? But when grandma drives from her house to your house, then grandma takes 30 minutes. Because grandmas drive slower than moms usually. Not always, but a lot of times. And that's okay. That's just because they want to take care and make sure they get there. Watch out for all the crazy drivers. All right, so why in the world does the same distance take different times? Like we already discussed, grandma's driving slower than mom. How can we figure out how fast they're driving? Well, we know that if someone is driving 60 miles an hour for 1 hour, they have driven 60 miles. If they drive 60 miles an hour for 2 hours, then they have driven 120 miles, right? So that tells us there is a distinct relationship between the rate at which you drive and the amount of time that you have driven, and that gives us the distance. So that gives us a formula. If we reverse that, we can write it like this. Distance equals rate times time. And if you look real close and you squint a little bit, it kind of looks like the word dirt. Especially if you put like a little line right here on the equal sign. Now it does say dirt. And if you think about a travel problem is from point A to point B, and you're traveling over the earth, and the earth is made of dirt. So if you can remember dirt as a travel formula, D equals R times T should be easy to remember. So let's go back to our problem. Let's see if we can figure out the rate of speed that grandma and mom are driving. Okay, so given this formula, we know what the distance is. We know that it's 20 miles. And we know that we don't know what mom's rate of speed is, but we know that it takes her 20 minutes. So basically, if we divide both sides by 20, then mom's rate of speed is 1 mile per minute. Okay? All right, so if we take grandma, it's still 20 miles, but grandma's rate of speed, it takes her 30 minutes. So 20, we divide everything by 30. I know it's odd seeing that variable in the front. You can just as easily rewrite it if that makes you feel better and put the variable in the back. It's entirely up to you. It still means the same thing. So we divide both sides by 30. Grandma is moving 2/3 of a mile in 1 minute. So she's way slower than your mom because your mom is moving 1 mile a minute, right? So let's see if that plays out. If this rate gives us the same distance for each of these. So your mom's rate, we go back up here, rate of time. So the rate for mom times the time of mom should equal the rate for grandma times the time of grandma. That should give us the same distance of 20 miles. So let's see. If mom is driving at 1 mile a minute for 20 minutes, and grandma is driving 2/3 of a mile for 30 minutes, all right, this side equals 20 miles. We put this over 1, we multiply, we get 60 over 3. 60 divided by 3 is 20. So we come back to the 20 miles. The distance is correct. So we know we figured it out right. So that means that mom is driving 1 mile per minute. And if you're driving 1 mile per minute, then there's 60 minutes in an hour. So 1 times 60 is going to give you 60 miles per hour, right? If grandma's driving 2/3 of a mile per minute times 60 minutes in an hour, then 2 times 60 is 120. 120 over 3 equals 40 miles per hour. And that's the rate of speed. If you want to take it up to miles per hour, you just figure out the minutes times the number of minutes in an hour. And that'll give you their speed or their rate. Okay? All right. So let's move on to the first example in the book. And that would be 92.1. So we have 2 trains that are traveling the same distance. One is an express train and one is a freight train. So we have express here and we have a freight train here, okay? And we need to know the rate of the express and the time of the freight in order to figure out the distance. So let's read the particulars. On Tuesday, the express train made the trip in 12 hours. The express took 12, and that's the time. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train was 15 less than the rate of the express. So you could write this 2 different ways. You could say that the express was the freight minus 15, or that the freight was the express plus 15. So either way should give you the same answer. So what we're going to do is this puts it in terms of if the rate of the freight train was 15 less than the express train. Okay? So the express train minus 15 was the freight. So we're going to do the E minus 15. And this is just going to be E. Okay? All right, now we can write our formula because we have something in each one of these sections that we can use to figure out. So we should be able to say the rate of the express times the time of the express equals the rate of the freight times the time of the freight, right? So the rate of the express, we don't know what that was, but we do know that the time was 12. So we can write this 12 times the rate of the express simply because I like to write my variables or my whole numbers in front of my variables. I like the coefficients. That's the way most people are going to do it. They're going to put the coefficient first, even though this is 12. Because you're multiplying, it doesn't matter which order you write them in. That's our rule for multiplication, the commutative property of multiplication. All right, our rate for our freight train is the rate of the express minus 15. So we'll write that in. The rate of the express minus 15. And the time of the freight was 16. So we're going to multiply that by 16. All right, so let's go ahead and distribute. We have 16 RE minus 240. All right, so let's subtract 16 RE from both sides. That leaves us with a negative 4 for the rate of the express, or times the rate of the express, minus 240. We divide both sides by negative 4. The rate of the express train was 60. Now we can figure out the rate of the freight because E minus 15, the rate of the express, is 60 minus 15 equals 45. All right, so now we have that this equals 60 and this equals 45. Now we can figure out the distance. So let's drop our rates and our times in. So the rate of the express was 60 times the time of the express, which was 12. The rate of the freight train was 45, and the time of the freight train was 16. 60 times 12 is 720. 45 times 16 is 720. Distance equals distance. So that is correct, and we know that the distance was 720 kilometers. Okay? You see how we solved that? Very good. Let's move on to 92.2. All right. So now we're talking about some girls that are hiking, and they're going to hike in to Lake Tenkiller, and then they're going to get a ride from Mr. Ali, who's a park ranger, on the way back because they're exhausted. So let's read the problem. The members of the girls club hiked to Lake Tenkiller, and let's go ahead and set up our chart. So they had a hike, we have a rate, and we have a time, and then we had a ride back. Okay, so the girls hiked at 2 miles per hour. So the rate of speed was 2 miles per hour. Mr. Ali gave them a ride back home at 12 miles per hour. Okay. Find their hiking time if it was 5 hours longer than their riding time. So their time for the ride, that's TR, their hiking time was 5 hours longer than TR, so TR plus 5. How far was it to Lake Tenkiller? So we need to find the distance. Okay, so we know that the rate of the hike times the time of the hike equals the rate of the ride times the time of the ride. We know that. We've proven it. That'll give us the distance. So the rate of the hike was 2, and the time of the hike was the time of the ride plus 5. The rate of the ride was 12, but we don't know the time of the ride. Okay, so now we can distribute. We get 2 times the time of the ride plus 10 equals 12 times the time of the ride. So if we subtract 2 TR from both sides, we get 10 equals 10 TR. So if we divide both sides by 10, 1 is the time of the ride. So we know the time of the ride was 1 hour. 1 hour, because they're talking about miles per hour. Okay, so if we sub in 1 here for TR, 1 plus 5 equals 6. So now let's figure out our distance. So the RH is 2 times TH, which is 6, equals RR times 12. 12 times TR, which is 1. 2 times 6 is 12. 12 times 1 is 12. So the distance was 12 miles. And we know that the ride was 12 miles per hour for 1 hour, and that the hike was 2 miles an hour for 6 hours. So the math works. We are correct. All right, we have one more, 93.3. Okay. You flip over. So let's see. Durant drove to the oasis in 2 hours, and Medill walked to the oasis in 10 hours. Okay, how far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? All right, so we have Durant and we have Medill. And we have the rate and the time for each of them. So, all right, Durant drove to the oasis in 2 hours. So his time is 2. He drove in 2 hours. Medill walked in 10 hours. So the time was 2 hours for Durant and 10 hours for Medill. How far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? So we're going to say that this is Medill walking and Durant driving was Medill's walking plus 16 because he was 16 faster. Okay? Does that make sense how I set that up? This was Medill walking. His driving was faster, 16 miles faster than the walking. So I hope that it makes sense for you. Now we still have to find the distance as well. So the distance equals what? All right, so now we drop it in. So we have the rate of Durant times the time of Durant equals the rate of Medill times the time of Medill. And it's important you always keep the same subscripted variable on the same side. Okay, so the rate of Durant was Rm plus 16, and the time of Durant was 2. The rate of Medill we don't know, but the time of Medill was 10. All right, so let's distribute. We have 2Rm plus 32 equals 10 times the rate of Medill. So we can subtract 2 from both sides, or 2 times the rate of Medill from both sides. This will cancel. 32 equals 8 times the rate of Medill. The rate of Medill is 4 miles per hour. He is a fast walker. That's pretty quick. So this is 4. So this is going to be 20 because 4 plus 16 is 20. So now let's plug in our numbers and find our distance. So the rate of Durant is 20 times 2, which is the time of Durant. The rate of Medill is 4 times the time of Medill, which is 10. 20 times 2 is 40. 4 times 10 is 40. They match. So the distance was 40 miles. Awesome. I hope that you guys see exactly how to solve these problems and understand how to set them up. And now you see why we learned how to use subscripted variables, because it makes sense to have two descriptive things when we're talking about constants and they need a description. Like they both have, we can't do rate and time. We need to know whose rate and time or what's rate and time. And this just gives us a little bit more information within our variable to find that. And it's a good thing. All right, that's all I have for lesson 93. I will see you in lesson 94. Did I say lesson 93? Lesson 92. Sorry. That's all I have for lesson 92. I have no idea why in the world I wrote 93.3 down. This is 92.3. I am so sorry. I am in a hurry, I guess. All right, so that's all I have for lesson 92. I will see you in lesson 93.